So as for the second problem, we're dealing with the joint density function within the circle. So it's within a circle. It's the value of this density function is a constant. And as for the first question, we need to find out what the constant is. And it's very easy. So we just do the integral like we have done in the first, dealing with the first problem. We just do the integral, and we get this pi radius square multiplied by the constant equals 1. So 1 equals 1 over pi. So it's very easy. Okay, as for the second question, we need to find 6 expectations. And we write them in 3 groups. Each group has two expectations. Take a look at the form with respect to x and y. We can see that both x and y has a circular symmetry, which means that if we switch the position positions of x and y, we find that the form of their joint density function or their non-zero region are still the same. Which means that as long as we find the expectations in the first row, we could find the expectations in the second row. They're equal. They're equal correspondingly. So we first need to find out expectation of x. So x, according to this definition with this Concord form, x multiplied by fx, its marginal distribution. So its marginal distribution. Just do the integration on the joint density function over. So we need to find out that the region, it's a circle, and it's actually combined with 2 functions, one-to-one functions, and the lower one it's minus with respect to x is y equals to minus square root of 1 over minus 2 1 minus x squared, and the upper is the minus y1. So this is its upper limit and lower limit. So we get the final result: 2 over pi square root of 1 minus x squared. So we substitute fx with what we got just now, and obviously after some observing, we find out that the function to be integrated it's an odd function because. The second, it's an even function, and x is an odd function, so the whole function is an odd function. However, the integral is symmetric to the origin, so we can find out that the whole integral should be 0. Without doing some really calculation, we find out that it should be 0. Okay, so both expectations of x and y are 0. And the second, the conditional expectation of x under the condition y. We read this definition still like that, and we need to find out the condition density function of x under the condition assuming y. So we write the definition of that. It should be the derivative of x and y, and so the denominator should be the very joint density function, obviously, of x y. That is a, and the denominator should be the cumulative marginal function of taking the derivative of y. That's still the marginal function. That's still the marginal density function of y. So it happens to be. So we just fy, and we don't need to calculate. We don't need to write the formula of fy because fy we know it has nothing to do with x. So we could. So this one is constant with respect to x. Still. Odd function in a symmetric interval, so the whole integral is 0. Okay, as for the third one, take a look at this. We could find out the x under the condition y. It's a constant. Y is treated as a constant. Well, we need to find out the region of x being non-zero. Take a look at this square. When we find a certain y. Take a look at as for this. So the x being the non-zero region of x is actually a rectangular. I think that's not easy to imagine. So the density function of So the density function of x is still a uniform function, but its region has shrunken. So it's just a rectangular. It used to be in a circle. Now it's just rectangular from minus minus square root of 1 minus y squared to the positive, something like that. However, when we write the form of the function, we only need to know it still has nothing to do with x itself. So it could be treated as a constant with respect to x. However, this cannot be called this cannot be called an old function. So actually, its integral should be 2 times its interval length. We cancel this, so we could get 1/2y. This is the only expression that is non-zero. We also get that. Okay, also along with its corresponding parts. And for the last question, we need to find out whether x, y are correlated. So we just calculate calculated the product of their expectations and their expectation of their product. We could easily find that their expectations. So EXY, the expectation of their product equals to equals to 0 because it's still an odd function in a symmetric interval, because circle is also symmetric, and their function to be integrated is xy multiplied by 1/pi. It's still an odd function. And this one is 0. And we get that EX is 0 and also EY is 0. So EX and EX multiplied by EY equals EXY, the expectation of the product. So actually XY are uncorrelated.